Okay, so what we're going to do first, in order to get good, like I said before, at factoring trinomials that have a leading coefficient that's no longer a 1, this is the most difficult kind of factoring that there is. But in order to get good at it, the way that I'm going to teach you is we need to get good at, or become really good at factoring out the greatest common factor of a binomial. So I'll do the first one with you. So take a look here. I have a 2 and I have a 12. What's the greatest common factor I can factor out of a 2 and a 12 there? 2. So this can be factored into 2. And then what would I have left over? I'd have an x minus 6. Okay, good. So I want you to get good at doing this part right here. Does that make sense? Okay, let's do the next one together. I have a 6 and I have a 3. What can I factor out? A 3. What would that leave me with? 2x plus 1. Very good. And then I want you to put a box around it. Okay, please do these other 8 right here. Let's go over these together. Wherever you're at, let's just come back together and let's talk about it. Okay, number 3. Let's take a look at the numbers that we've been given. We've been given a 5 and a 2. Is there anything that's related to a 5 and a 2?
You can do a 5 and then parentheses x.
Number 3.
Number 3.
Mm-hmm.
And 5 and parentheses x plus 0.4.
Oh, okay. Yeah, you could do that, definitely, right? But if I just want to have 5 and 2, is there any number that they share in common? Yeah, they share 1. So here's what I was asking. I was getting at this. 5x plus 2. That you can always factor out a 1. There's another one like this somewhere in this set of problems. You guys see it? Which one is it?
6.
Number 6. What can you factor out? Yeah, you can factor out a 1. That will leave you with a 2x plus 5. All right? Let's talk about number 4. Anybody get number 4? What'd you guys get? Yes, Cecilia. Good. And x minus 3, you are correct. Very good. Number 5. Anybody get anything? Yes, sir.
5 and then
X minus 3. Very good. Awesome. Number 7. Anybody got anything? Yes, sir.
3.
Yep. X minus 3. Yep. Very good. And number 8. Anybody got anything for number 8? Someone different? Anybody? Anybody else got something different? Now, there's a negative sign, but don't let that fool you. What do you think? Yeah. Negative x plus 2. You could have that, or you could have this. A negative 2, and you could have an x minus 2. Both of those are equivalent. You can have either one of those. All right? Okay, now, everybody got that down for the first part? Okay, now here's the more difficult part. We're going to factor ax squared plus a bx plus a c, where the a is no longer equal to a 1. You see, beforehand, the a used to be a 1. Now, it's not going to be a 1. So let me show you where we are on our factoring flowchart. Okay? Here's where we are with this flowchart. We're going to start. We're going to do this first. Can we factor out the GCF? That's what we just practiced. If we did, we're going to do that. Then we're going to say, is it a binomial? And the answer is going to be no. Is it going to be a trinomial? The answer is going to be yes. Is the leading coefficient a 1? And the answer is going to be a no. Okay? So what we need to do is use diamond problem to split the middle term. So this is where we're at right now. Do you guys see that? We just spent the whole last week over here in the yes side using if the leading coefficient was a 1. But today it's going to be a no. We're going to use a diamond problem to split the middle term. Then we're going to factor by grouping. And then we're going to be done. So this is where we are on our factoring flowchart. Does this make sense? Okay, does everyone have this flowchart out? Make sure you do. Awesome. Let's go back here. And I'm going to give you an example, and we're going to go through the process together. So we're going to factor 2x squared minus 11x plus 5. And over here on the right-hand side, we're going to write down the process here that we're doing. Okay? We're going to write down the process. So, the first thing we want to notice is this a trinomial, yes or no? Yes, this is a trinomial. Okay? Is the leading coefficient a 1? No, it is not. What is the leading coefficient? The leading coefficient is a 2. All right? So the first thing that we're going to do, step 1, is we're going to multiply. We're going to multiply our first term first coefficient by the last coefficient. So we're going to multiply 2 times a positive 5. And we're going to get this. We're going to get x squared minus 11x. And then what is 2 times 5? Positive 10. Okay, that's step number 1. Now, does anybody notice something really, really cool about our new equation that we just created down here? What's really cool about that? Anybody see it? What's that? What's the 1 part? Yeah, the leading coefficient is now a 1. You guys see that? So our second step, what we're going to do is we're going to use a diamond problem. Use a diamond problem just like we would before. And solve our new equation. Solve our new equation, or our new, it's not, yeah. Our new term. Or expression is what that's the one I was looking for. Okay, so here's what we're going to do. Alright, let's talk about it here. What number goes on the top? 10. What number goes on the bottom? Negative 11. Very good. Okay? Now, we have a positive on the top. We have a negative on the bottom. You guys tell me. Positive top, negative on the bottom. They both have to be what? They both have to be negative. So negative and negative. Okay, let's look at the factors of 10. It's always the last one. 10 can be 1 times 10. Can I create an 11 out of a 1 and a 10? I sure can. So 1 goes there and a 1 goes there. Sound good to you? Or, sorry, that's what I meant. Forgot my 0. Okay, everybody go with step number 2. Okay, step number 3. Here's what we got going on so far. We are going to use the answer from the diamond problem to split the middle term. And I'll tell you exactly what that means. Split middle term. That's step 3. So here's what that looks like. The middle term is this one right here. Do you guys agree that that's the middle term of the problem? The negative 11x. You guys agree with that? Okay, I'm going to split up negative 11x like this. Negative 1 and a negative 10. And here's what it's going to look like. So I'm going to write this down. 2x squared. Now instead of a negative 11x, I'm going to write down a negative 1x and a minus 10x. And then finally a plus 5. So does everyone realize that all I've done so far is I have rewritten negative 11x as negative 1x minus 10x. You guys see that? Yeah. Okay, cool. Now that you're with me here, how many terms do you see on this new equation or this new expression? How many terms do you see in that line right there? You see 4 terms. I want you to now group them in groups of 2. So what we're going to do is we're going to group terms by 2's. All right? Now, here's what we're going to do. Okay? We're going to look at this first factor here. Okay? 2x squared minus 1x. Okay? Is there anything you can pull out, or what can you factor out from a 2x squared and a negative 1x? What do they both have? They both have an x. Very good, right? So I can factor out an x. What does that leave me with? 2x. What's that? Minus 1. Awesome. A 2x minus 1. Okay? So far, so good? Okay, good. Now, the goal here, here's the goal from all this. You see this binomial I have left over? Okay? What I want to do is I want to match that same binomial over here in this part. So what I'm going to do is I'm going to look for a 2x minus 1 that I can factor out of this one so I can put it there. How could I turn negative 10x plus 5 into a 2x minus 1? What do I have to factor out in order for that to happen? Yeah, Tyler, what do you see? He says a negative 5. Okay, if I pull out a negative 5, okay, does that leave me with a 2x minus 1? Is that true or false? Let's see. What's a negative 5 times a 2x? Is that true or false so far? That's true. What's a negative 5 times a negative 1? So is that true? Okay, do these two terms match? That's the question. Do my two highlighted terms match? Good. Then, if they match, and this is the most important part, if they match, the answer to the entire problem is staring at you in the face. Do you guys see it? Okay, maybe not. I'll show it to you right now. So the answer, remember, we started with this. We started with 2x squared minus 11x plus 10. This is going to factor to the product of two binomials, just like the other one did. One of the answers is 2x minus 1. And the other answer is right here, x minus 5. 2x minus 3. Okay, here's the next problem we're going to do together. We're going to follow that same process. 5x squared plus 2x minus 3. Okay, first things first. Is our trinomial, what's the leading coefficient of our trinomial? 5. Is that equal to 1? No, it's not. So what am I going to do? Multiply the 5 by the negative 3. And what number would I get? Good. So we're going to write down x squared plus 2x and then minus 15. So far, so good? Okay, good. Now, do I have a trinomial? Is the leading coefficient a 1? Yes. So what am I going to do? I'm going to use the diamond problem. Very good. Okay, what number goes on the top? Negative 15. What number goes on the bottom? Okay, you guys tell me. I have a negative up top. I have a positive down below. So one of them has to be positive. One of them has to be negative. Which is the bigger one? And that's the bigger one. Very, very good. Okay, can you guys tell me? Let's see here. 15. What'd you get? 3 and 5. Yeah, you already figured it out, right? 3 and 5. Oh, thank you so much, because 5 is bigger, huh? Okay, so 5 and 3. All right. Next part of my process. I'm going to split the middle term. I'm going to say 5x squared plus 5x minus 3x minus 3. So again, I just want you to know, instead of writing down 2x, I'm going to write down 5x minus 3x. They are the same thing, aren't they? So notice I haven't changed the value, right? Because 5x minus 3x is 2x. Same exact thing. Okay, now I've got 4 terms. What do I do next? I group them up. Yeah, you got it, right? Okay, take a look at your first binomial. What's the greatest common factor you can take out? So a 5x. Do you see why it's important to be really good at this? Okay, what do you have left? X plus 1. Awesome. Beautiful work. So tell me, guys, what are you looking for in that second term? Yeah, you're looking for an x plus 1. So how can you get an x plus 1 out of that? What do you have to factor out? Yes, you guys are gotten it. If I take out a negative 3, let's see here. Is a negative 3 times x, is that equal to negative 3x? Yes. Is a negative 3 times 1, is that equal to negative 3? Yes. Do these match? Yes. So therefore, the answer is staring you in the face. When we always write down the original problem again, it was 5x squared plus 2x minus 3 is equal to the product of which two binomials? What are they? X plus 1 and 5x minus 3. Okay, we're going to factor 3x squared minus 5x and then a plus 2. Okay, is the leading coefficient a 1? No, it's not. So what am I going to do first? 3 times positive 2. What's that going to give me? So I'm going to write down this. X squared minus 5x and then plus 6. You guys so far so good? Okay, good. Now, is my leading coefficient a 1? Yes. So what do I use? Diamond problem. What number goes on the top? What number on the bottom? Okay, you guys tell me a positive top, negative on the bottom. They both have to be negative. Very good. Okay, let's see here. Let's take a look at the factors of 6. I could use 1 times 6. Can I create a 5 out of that? Not if they're both negative, right? Can't do it. How about, what's the next one? How about 2 times 3? Can I do that? Yep, I sure can. So a negative 2 and a negative 3. So far, so good? All right. So now I'm going to split up my middle term. I'm going to have 3x squared. Okay, with me so far? Okay. Oh, right here. Minus 2x minus 3x, and then finally I'm going to have a what? Plus 2, right? Is that what I have? Wait a minute. Oh, it's plus... No, it's plus 2. It's the original one, right? Yeah. It's the original one, yeah. Okay. Still following me? Yeah. All right, okay, good. Okay, let's group them together. Let's do this, and let's group this. So it doesn't matter how you group them. Okay, let's see here. What can I take out of that first term there? Anybody see anything they could take out? A 1 and an x, right? So I'll do an x. What's that leave me with? 3x minus 2. 3x minus 2. Okay? So what are you looking for then? What are you looking for out of this one over here? You're looking for a 3x minus 2. Whoop, that's the wrong one. Isn't it almost there? Yeah. It's almost there, right? So this one has negative 3x plus 2. So think, what could you factor out that could turn that into a 3x minus 2? A negative 1. Very good. That would give you a 3x minus 2, wouldn't it? And if you want to check really quick, go ahead. Negative 1 times a 3x, that's a negative 3x. Negative 1 times a negative 2, that's a positive 2. Your life is good. Your life is good. Do those match up? Yes, they do. Therefore, the answer is staring us in the face. So we have a 3x squared minus 5x plus 2 can factor to the product of two binomials. Give me one of the products. 3x minus 2. Give me the other one. X minus